Welcome to our tutorial on fast reliable file transfer over UDP. This is Sirisha and my teammate is Tanvi. In this lab, we were asked to transfer a 1 GB file over two different environments. The first one was with a delay of 10 milliseconds and 1% packet loss, and the second one was with a delay of 200 milliseconds and 20% loss. UDP protocol was used for this because UDP is faster than TCP. Uh, because in this scheme, in the UDP scheme, there are no acknowledgements involved. But the disadvantage of using UDP is that it is unreliable and the packets are delivered out of order. So we have to add additional features like sequencing, multi-threading, multiporting, and negative acknowledgements for retransmission of drop packets in order to make sure that the file gets transferred correctly. UDP is used for large file transfers across internet. Even though TCP is a more widely used protocol for file transmission, it falls short in comparison with UDP when it comes to file transferring large files because of its speed. This is why UDP is preferred for this application. The way TCP and UDP protocols work are that they break down a large file into individual packets. These packets are sent across the internet, hopping from one node to the next until it finally reaches the destination. Once the packets have arrived, the data is reconstructed and the file is back to its original state. In terms of reliability, UDP has drawbacks compared to TCP. You are essentially trading reliability for performance. Hence, the main advantage of UDP is speed. Multi-threading is the ability of a CPU to provide multiple threads of execution concurrently supported by the operating system. A thread is a path which is followed during a program's execution. Majority of programs written these days run as a single thread. Multi-threading is implemented so that two or more tasks can be executed simultaneously. The concept of threading is designed due to the problem of fast and regular changes in the technology these days.
We are now going to demonstrate how to transfer a 1 GB file between two nodes over a 100 Mbps link. So I've already created a 1 GB file. As you see here, it's if you see the properties, it is 1 GB. So let's go ahead and start the server. So this is my server code. I just compiled it, and let's run the server on port number 10,000. Okay, right now the server is up and running.
I'm going to run the client on a different system now. I found out that the IP address of the server is 192.168.1.17 using the ifconfig tool. Now I am going to type in the file that I want to retrieve from the server side, which is lfile.txt. As you can see, the file has been received and the time taken to do this was 283 seconds. The fastest that we got was 281 seconds and the corresponding throughput was 3.5 Mbps.
So we made a few changes to our code and um, ran the code once again on two different Ubuntu machines. We introduced two scenarios. One is um, a loss of 1% and a delay of 10 milliseconds between the link, and that the time duration which was taken to send the file was 364 seconds. 364 seconds, as you can see, it's 364,896,071 microseconds. And using this time, we calculated the throughput, which came up to 2.740 Mbps. Similarly, we introduced another scenario where the loss was 20% and delay was 200 milliseconds. As you can see, the time taken to complete the file transfer was 557 seconds. And using this time, we once again calculated the throughput, which was 1.7950 megabits per second. And yeah, we used attached as the screenshots for both the scenarios.
In order to check whether the file that was received was exactly same as the file that was sent, we're going to use the md5sum command. MD5sum is a computer program that calculates and verifies the 128-bit MD5 hashes as described in RFC 1321. MD5 has functions as a compact it actually functions as a compact digital fingerprint of a file. The MD5sum command prints a 32 character checksum of the given file using the MD5 algorithm. Let's now run the MD5 command for the file that was received, which is lfile.txt. Okay, now you can see that this is the MD5 that was received. So let's now check if the same MD5 32-bit checksum is obtained if we run the MD5 command on the server side.
As you can see, the MD5 obtained for the file is same as the one shown in client at the client. So this shows that the file has been successfully transferred, and it is the same file which is being transferred since the MD5 value is same for both. So this ends our tutorial, and stay tuned for the next. See you guys. Bye.